All right, so we are putting together all the different um, features and uh, features or simplified versions of a rational function. I have discussed each one of these separately in different videos. I will update this video with links to each one of those if you want to look at a more focused video for each one of these features. Okay. All right. So right now, I'm going to give you a couple of examples and we will find each one of these seven things for one, one function basically. All right. So let's start with the first one. So we have this is our given f of x equals x plus 1 x plus 1 over x squared minus 1. All right, so the first one, so I might have to erase some of these things after, so you may have to pause as needed. All right, so let's do the factored form. So this is your function right here. The numerator is already factored out because the highest exponent of x is 1, and also you don't have a common value in the coefficients. You have 1x plus 1, so therefore you don't really need to factor 1. So the numerator, as far as factoring is concerned, is already good. However, the denominator can be factored out. In fact, that is a difference of two squares. So, all right, so for the first one, you have factored form. Okay, so we will just need to factor the denominator. So that's going to be f of x equals x plus 1 over, and then you have two variables. This is a difference of two squares. So therefore, you take the square root of the first term and take the square root of the second term. All right, the first term is x squared. The square root of that is x. So you put x on each one of the parentheses or one of the factors. Square root of 1 is 1, and one is plus, one is minus. All right, so this is the factored form. Now we want to do the simplified form. All right, so the simplified form therefore is if you have something in the numerator that's also in the denominator. Well, yes, we do, because you have x plus 1 over x plus 1 and x minus 1. The numerator is essentially a binomial, and we can put that in parentheses. So therefore, these two are the same, right? So we can factor that out. And so what's left? In the numerator, there's nothing left but 1 over x minus 1. So this is the simplified form, okay? Now, the next one is the vertical asymptote. So remember in our lessons about vertical asymptotes, this is the value of x in your denominator that will make it 0. Well, look at your simplified form. You have x minus 1, right? That is the denominator. So therefore, if you want to find the vertical asymptotes, or in this case, there's only one, the vertical asymptote is what value of x will make it 0. So in other words, you just look at your denominator, the leftover denominator, x minus 1. You equate this to 0 and solve for x, okay? Plus 1 plus 1. So therefore, your x equals 1. This is the vertical asymptote, okay? Now, number four, we want the holes, okay, or holes if there's multiple one. But in this case, there's only one. How do we find it? Well, remember that factor that was common in the numerator and denominator, that's x plus 1. That has something to do with a hole. In fact, you take that common denominator, common value, x plus 1, and equate that to 0, okay? And we solve for it. I'm going to subtract 1 on both sides of the equal sign. Therefore, x equals negative 1. So this is the x value for that. To find the y value, you use the simplified form. So f of negative 1, we will substitute that value. 1 over negative 1 minus 1. So I substituted it here. This x value, I substituted it here. So now you have 1 over negative 2. So therefore, your whole is negative 1 from this x, comma, negative 1 half. That is the whole for this particular function. Okay? Now, I'm not going to have space, so I'm going to erase all of it to move on to 5 through 7. Okay? All right, so the next question is x-intercepts. So remember, when you have an x-intercept, the value of y in the x-intercept is equal to 0. Okay? So let's repeat that. For the x-intercept, number 5, x-intercepts mean y equals 0. So that's the f of x. So therefore, you can substitute y equals 0. You can say 0 equals x plus 1 over x squared minus 1. Okay. Now, if you put an over 1 here, you can actually cross multiply. So when you cross multiply that, you have x plus 1 equals, and multiply it this way, 0 times whatever is just going to be 0, right? So if I subtract 1 on both sides, then x equals negative 1. So that means this is my x-intercept. So your graph will cross the x-axis at x equals negative 1. And that's the only one, okay? All right, so um, let's do the y-intercept. Okay, so the y-intercept, number 6, the y-intercept will be, remember, if the x-intercepts, the y equals 0, and then the y-intercept, the x equals 0. So therefore, from your equation, you can do f of 0 equals, substitute 0 in your equation. Every time you see x, you replace it with 0. So 0 plus 1 over 0 squared minus 1. And when you simplify that, that's going to be negative 1. So that your y-intercept, y equals negative 1. Okay, or the point for this would be 0 comma negative 1. Okay, because the x is always going to be 0. Okay, horizontal asymptote, I misspelled the horizontal and I missed the on. Okay, horizontal asymptote. So horizontal asymptote, there should be an on there. All right, number 7. So we have, for our horizontal asymptote, we need to compare the degrees of the numerator. Okay, so what's the degree of the numerator? That we will call it n, that's equal to 1. The degree of the denominator is 2, m equals 2. And then we can say, because 1 is less than 2, so n is less than 2. So therefore, your horizontal n is less than m. Okay, so this is situation number 1. So remember, you have 3 situations where n is less than m, n is equal to m, and then n is greater than m. Well, this is the less than 1, so therefore your horizontal asymptote is y equals 0. Okay. All right, so let's move on to a different example. We have a second example for this worksheet, okay, for this question or set of questions. There's a lot of questions here. Okay, so again, there is horizontal with an on there. Okay, the second one is f of x equals 1 over x squared minus 4. All right, first one is factored form, okay? Well, can you factor 1? Well, that's it. That's it. But the denominator, you can factor it some more. That's, again, a difference of two squares. X squared is a perfect square. 4 is a perfect square. You have a minus in between. So therefore, that's a difference of two squares. You factor them out. Square root of x squared is x, so you get an x for each one. Square root of 4 is 2, so one is positive, one is negative. This is your factored form, okay? Number 2, a simplified form. Do you have anything that you can cancel from the numerator and denominator? Nothing really. So this is the simplified form. That's the simplified form. Okay, next one. Vertical asymptote. Well, the vertical asymptote is the value of x in the denominator that will make it 0. So you have, this is your denominator right here. So I'm just gonna say x plus 2 times x minus 2 will make it 0. So therefore, these are already factored. We can set each one to 0. X plus 2 equals 0, x minus 2 equals 0. Solve for each one. So x equals negative 2, and add 2 on both sides, so therefore x equals 2. So you have two vertical asymptotes. Okay, x equals negative 2 and x equals 2. Number 4, wholes. Wholes is do you have a common factor in your numerator and denominator that you can cancel out? Nope, not really, because numerator only has 1 as a factor. So no holes for this problem. Okay. All right. Number 5, x-intercept. Okay. So x-intercept, you set the, I'm going to erase this. Okay. So for the x-intercept, remember your y is equal to 0. So we can set that, substitute y. So f of x equals 1 over x squared. Actually, I want the factored ones, okay? Because that's a much better way to work on it. Okay, so number 5, x-intercepts. Okay, so where y is equal to 0, so that means your f of x is equal to 0. So I'm going to say 0 equals 1 over x squared minus 4. If you put over 1 here, then you can cross multiply. 1 equals 0 times something is 0. Well, is there a case where 1 is equal to 0? No, 1 is not equal to 0. So this only means you do not know x-intercept. So meaning it will not intercept, it will not hit the x-axis. No x-intercepts for this function, okay? And there are a lot of cases when you don't have x-intercepts really, okay? All right, so next one is the y-intercepts, okay? So number 6, y-intercepts. Okay, so this is where x equals 0. So therefore, f of 0 equals 1 over, substitute x equals 0 on your equation. So you have 0 squared minus 4 or equal to negative 1/4. Okay, so therefore your y-intercept is going to be equal to negative 1/4 or 0 comma negative 1/4. Okay, good. All right, lastly, horizontal asymptote. So now we will compare the n degree and the denominator degree. Well, the numerator only has 1. It doesn't even have an x. So therefore, that degree is 0. It does not have any x at all. And then m, the denominator degree is 2. Well, we can say that n is less than 2. So therefore, your horizontal asymptote is just going to be y equals 0. Okay, so again, if you want to learn more about each one of these, there will be a link for each one of these lessons if you want to work on a more focused video for each one. All right, if you have any question, as always, write anything, any comment that you have any comments on, and I'll see you next time.